That's who I am, Lee Gregory, and Civil BIM and IFCs. And this will be a short presentation because we've done a few webinars on this. I just want to go through some of the smaller parts just to make you aware of some things in BIM and IFCs, which are the International Foundation classes. Just so you're aware, because everyone's talking BIM, most people only see little bits and pieces of it. It's mainly a lot of it's jargon, you just have to know what it is. We're members of buildingSMART, which is the international organisation that defines Open BIM, or IFCs as they're called, for passing data around. This is things like the Queensland government says you're supposed to be using open data, no proprietary, undocumented formats. That's the future. We're also foundation members of the Open BIM Alliance, which a whole lot of vendors got together to see if they can pass IFC data around and see what the problems were. We're also, I go to the buildingSMART international conferences and things where we actually define the international IFCs. So we're there putting our input into it about what they're going to be. And I've been involved with a thing called an IFC Model Setup Information Delivery Manual. The problem with all these things, they have incredible names. This is just trying to tell people how you should set out a large job using IFCs and really telling architects how to get around the fact that the world is not flat. That's really what it's all about. Because everyone in BIM tends to be more architects. There's another project I'm involved with, which is IFC Alignment, IFC Roads, IFC Rail, IFC Tunnels, and IFC Bridges. Now, the fact that these projects are on tends to imply they were never in BIM. So just keep that in mind why I'm involved with these projects. And I'm very lucky. I go to Japan for the next one. Every 6 months there's a conference, a get-together on defining and talking about what's happening with all these things. The next one's in Japan in October. Tough life, isn't it? Horizontal and vertical BIM. I differentiate between these simply because most people talk about vertical BIM, which are called buildings. That's why it was building information, meaning the noun, building, not the verb to build. People try to fool you, but it's basically vertical buildings. We're interested in linear, horizontal stuff. So everything pretty well has been for vertical. No, it doesn't matter what they tell you, that's what it's all been about. And that's not very suitable for long, large, longitudinal projects. If you look actually at the definition of IFCs, I won't go through into it, but this is actually part of the definition. And what you see on that left-hand side there is a list of the elements they have. And if you can read it from back there, they've got great things like walls, windows, slabs, footings, doors. You don't find road, you don't find anything else in there. That's it. They're all building type things. That's the definition. No one can get around that fact. They can't tell us it's there for a sort of centre line when it's not. The one we have to use is a thing called IFC Building Element Proxy, which is just a general element saying, here's a tri-mesh. That's what we have to use most of the time, because very few of the times do you guys design windows. What do we need for civil BIM or horizontal BIM? Large coordinates. You need to handle large longitudinal projects. You need a thing that can go for 20 or 40 kilometres. You need arcs, which are arcs in plan, which means they're actually a helix in 3D. That's not a circle in 3D plane, so it's a helix. You need strings without diameters. Now, I spoke to the people at the last BIM conference. I said, how come you guys can't take strings without diameters? You have to turn them into little pipes. I said, well, all the architectural people got together years ago, the vendors, and said, we don't have strings without diameters. Everything has to be a pipe. Hence, most of these architectural packages stuck with that problem. We also have attributes on strings, vertices and segments. People say you don't need strings without a diameter. Well, what in friggin' hell's a centre line? It's got no diameter. What about a cadastral boundary? It's got no friggin' diameter. So anyone tells you that, it's just pulling your leg, trying to get around their own product's inabilities. Names for strings. We've only been using this in Australia since about the 1980s and earlier. We have a string naming convention. There's no such thing in buildings. They don't have names for all these things. They just make up crap along the way. We've got to have a naming convention. It's fundamental to everything we do here. We use a naming convention. Null Z values. We get things from people saying, you've got null Z values in there. How can we draw it in 3D? Well, you don't, mate, you don't. But how can we do it in our 3D package? Well, you've got a bad package. They said, well, everything has to have a Z value. Are you crazy? Your cadastre, how often does that come with a Z value? Oh, you put 0 in there. Well, some idiot's going to think it's at 0, aren't they? I mean, surveyors do not want to put in data that's not valid. You need a null Z value. Drainage, sewer, pits and pipes. Yep, we need all those sorts of things. Tins for surfaces, and you've got to be able to take hundreds of millions of those darn points and triangles, and tri-meshes for 3D objects. We want alignments, horizontal and vertical geometry. The whole thing about civil is that is your grid. Paul did one for buildings, a nice rectangular grid. They have that in IFCs. We all use chainage offset. Everything in civil uses that as its reference grid. So you need at least an alignment. People say, oh, we can approximate it. Bull crap. The RMS says the thing has to be plus or minus 1.5 millimetres. And so you're going to approximate this thing? Go on. So you need that in there as well. You need linear referencing that you can use chainage offset. Again, everything we do, that's how we say for everything, it's chainage offset. Transition curves, spirals, cubic parabolas and whatever. What drafting package do you know has got a transition curve in it? None of them. So how in hell can you use it for civil design, work? Especially railways, they're nothing but transitions. And you need a published format if it's Open BIM that everyone can get free of charge. It's a text format, so you don't have to pay some vendor to get access to your own data. So there's sorts of things we need for civil BIM. You also know people who can understand all these things, who know about longitude and latitude, heights, coordinate systems, map projections, and how to bring all that together. Now, buildingSMART, they're not stupid there. They're very intelligent people. They recognise all these deficiencies for horizontal BIM, and they've set up a thing called the IFC Model Setup Information Delivery Manual, again, and that's about how to bring together federated models, because they suddenly realised that, hey, if I've got something 40 kilometres long and I put it into an ordinary system, you're out by a few metres. Wow. So they also set a project up for looking at roads, rail, bridges, tunnels. So all those things they realised were deficiencies, and there's all these big teams getting together to try and sort it out. You can imagine what that's like though. Teams from around the world, by committee. It's great work, but it's getting there. They decided the most fundamental thing though was the alignment. You have to have a definition of alignment because that was for everything. And that's what they've been working on first. So they almost have got an alignment. Well, I'll show you what we're up to. Then they're going to build all the rest on top of it. So the solution for the model setup was you have to be able to worry about map projections. It was simple things. I wrote most of this. Hey, find out what your map projection is. Write it down so everyone else uses it. Simple things like that. It was not difficult. And then basically, if you've got a large project, really what you've got is a set. You can work locally, no problem, as long as you're staying about 1 kilometre. And you need to know a local helmet transformation to get it into, say, MGA coordinates. Basically, a few things like that. You also probably want a Z shift, because most of us work in AHD, Australian Height Datum, or the New Zealand Datum. They tend to have 0 at the bottom of the building and start going up, right? So it sort of catches you out a bit. So basically, that's just a delta Z, so you can fix everything up. Not really hard rules. And so if you've got a long linear project, all it came down was define a projection for the whole system. First, you have to tell them what a projection is, but define it. And then you can work locally on all these little areas in your other little systems like Revit or ArchiCAD or something like that. But you need to get people who know what they're doing to find 2 points in there where they know the NGA coordinates. We all say get 3 or 4 points. So then you can work out a little 2D helmet so you can bring it back into the full system. Not very difficult. That's all you have to do, and things do fit together. So that's all this whole thing was about, how to bring this data together. It's taken us 2 years. IFC Alignment 1.1 was the other project, and it's got a long alignment string with independent horizontal and vertical geometry in terms of horizontal segments, straight arcs, certain number of transitions, not the one in Western Australia for rail or the one in New South Wales. And I'm not even certain if it's got the road one we use in Australia, but it's got some transitions. And vertical segments of straights, arcs and parabolas. Hey, the stuff we've been using our whole lives. So that's as far as this definition went, and also has a thing called a 3D alignment, which is not what you think it is. It's breaking alignment up into little straight segments. That's so you can show it in a package that doesn't know about alignments. And tins. So this whole project, that's about as far as it got, more or less what we had about 1991. But it's a good start. So basically, here's some data. We're working with Main Roads here on a project. We're about to write out this data. We wrote it, and we can write it out into what's called IFC 4.1, which is coming out, I think, early next year. So we wrote that data out, basically, in IFC 1.1, and we read it back in again. And so, more or less, it came in okay. We had strings in there, we had alignments in there, and we had tins. And we presented that in October of a year ago. So we are getting places, they just have to ratify all this. So they are starting to think about civil, and you can see that's how far we've got. Well, none of that was there before, so don't let anyone fool you about BIM, that it was good for civil. So where are we? Large coordinates. IFC files can handle large coordinates. The whole myth of this is the software that people are using, architectural packages tend to not be able to handle them. But the IFC has no problems. We've handled lots of jobs here with the RMS and TMR. We use MGA coordinates. How to handle large and long projects? Again, if you do it all in MGA, there's no problem, but you have to tell these other people how you bring your data together. So that's why we have the setup thing. IFC 4.1 has helixes for arcs. There's no problem with IFCs with strings without diameter. It's the package you're using. Even Celebri can't take things without diameters. You know, friggin' hell. Attributes on strings, vertices and segments. You've got them on strings, not really vertices and segments unless you start clumping things together. So use 12DA for that. There is a name in there. Every IFC object has a name, but it's optional. So any of our people are using, like a government authority should say, you have to have your string name in there. So it is there, we can pass it around. Nothing about null Z values, they have no idea. You know, if you can't draw it in 3D, they do not understand it. It already has handles with IFCs for pipes and pits and all that, that's quite okay. IFC 4.1 has the alignments in it, sorry, tins I should say, but sorry, it's in alignment 4.1, but not super tins. We're the only package in the world that has super tins, so I suppose that's not unusual. The problem with lots of these committees, they get together and you get the vendors there and you end up with the lowest common denominator. That if one of the packages can't handle it, they say, oh, we don't want to have that in there. So you end up with the least smart things. Alignments are in there for IFC 4.1. It's got alignments, so you've got unilinear referencing. It's got most transitions are in there, lots of weird rail ones for Europe, because there's lots of Europeans there. It's got a published format, and I can tell you from my conversations there aren't many people there who really understand it because they're all architectural side. There's nothing wrong with architectural. I know nothing about curtain walls. I know nothing about structural design of a building, so I don't tell them how to do it. But they like to tell us when we're there about how we should be doing civil design. So I think there's a lack of knowledge, is why you guys, you have to get involved. You're the ones who've got to get in there and tell them, this is what we need for civil work. Stop telling us crap about what you do for buildings, and this is what we need for our civil work. Thank you.